Okay, this is a follow-up video to my Kirchhoff law video, and this is one is working through an example, and this is the same example or question you've got as your first question of your Schoology quiz. Now, here's the circuit that's set up. There's two batteries in this and a couple of resistors, and the question asks for you to find R. So R equals question mark. What's R? And they give you some information in the question. They also tell you that I2 is equal to, I think, 6/7 of an amp, which is about 0.86 of an amp. So this is the information you're given. So let's go through and work this out, how I'd work it out. Now I know there's two laws I could use. We'll just remind ourselves of them. There's the current law, and there's the voltage law. I'm going to write the current law down. I'm not sure if I want to use it yet, but I've got a junction here. I'm going to write the law down because it could be useful. So I1 comes in and I2 and I3 come out. So I know I1 equals I2 plus I3, and I2 is 0.86. So I1 equals 0.86 plus I3. Well, there's my current law written down and useful. That doesn't help me find R at the moment, does it? Because it doesn't have any R's in it. So really I want to set up an equation that has R in it. Now I've got some freedom here. The voltage law is, remember, if you go around a loop, the voltage, the total voltage, the sum of the voltage, is equal to 0. So I'm free to choose my loops, and there's actually 3 loops here. There's one loop which is around here, that's 1. There's another loop which is around here, that's 2, and there's a third loop which is around this circuit here, 3. So which one is going to be helpful for me? Well, I want a loop that has R in it. So the one that went around just in this, from the 12 to the 4 ohm to the 8 ohm, that's not helpful for me at the moment, I don't think, because there's no R in it. Any of those other two could be useful. So I might just worry about this one here. I can choose the direction of my loop. I like batteries being the normal way around. I like going through batteries the normal way. So I'm going to start my man here. He's going to walk this way, and he's going to walk around this loop here. That's going to be my loop. So he starts at this point here. So he's walking. He gets to a resistor. Let's keep it on red. He gets to the resistor, and he's going the same way as I2, the same way as the current, so it's negative. So it's negative, and we know V equals IR. So I've got that, 0.86 times R, I've got that, 8. Cool. And then he's walking. He's going to go through another resistor. This time though, he's going the opposite way as the current's going through. So that becomes a plus. Do I know the current? I don't know I3. So I3. I don't know R. Why did I put I3R? Because I'm working out the voltage, and voltage equals IR. So I times R is the voltage here. I'm walking. I then go the proper way through a battery, plus 6 equals 0, because I've gone around the loop. And when you go around the loop, it equals 0. So that's an equation, and I can solve that now for R, and I can get the answer I want to. Except I don't have I3 yet. So that's I guess the next thing I need to get. Well, I know from up here, my current law, that I3 is equal to, or plus 0.86 is equal to I1. So if I can find I1, I can find I3. Okay, we're getting there. So maybe I want to look up and write another equation, and let's use blue for this, going around this loop. Because if I go around this loop, I go through this guy here, and he's got I1, so that's going to be handy. I'm going to go all the way around and do a voltage loop around here. So where am I going to start? Maybe I'll start here. So here's my man. He's walking that way. So he goes through 12 volts first. So he goes plus 12. He's walking, walking, walking. He goes through this resistor. Remember, V equals IR. I is, we don't know, I1. And R is 4. Because we're going the same direction as the current, it's a minus. So I1 times 4. Walking, 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 walking. He now goes through this resistor, which is 8. And it's going the same direction, so that's also a minus. Minus I2, which we know, I might just put the number in for it, 0.86 times 8. And that equals 0. So now I've got an equation with I1 in it. I can solve this equation to find I1. So I've got 12 minus 4I1 minus 0.86 times 8 equals 0. If I rearrange that, I get 4I1 equals 5.14. So I get I1 equals 1.28 amps. Okay, that's cool. Now I've got I1. I know I1 equals 0.86 plus I3, so now I can say I3 equals 1.28 minus 0.86, and I get 0.428 amps. That's very handy because this I3 is now going to go straight in here, and I can solve this equation, which was my first equation, which had R in it. Remember, my whole aim is to find R. So now I can solve that equation. I might just move down, give myself a bit of room. So now I can put it in, and I've got negative 0.86 times 8 plus, I now know I3, which is here, which was 0.428 times R plus 6 equals 0. And when I rearrange that, do the math to rearrange that, I get R equals 2 ohms. Done. So it's not easy. It's a long process where you've got to work on multiple loops, and you use these two laws, the current law and the voltage law. But each individual part of the whole process is easy. The current law is easy. It's really easy to use. The voltage law is easy if you just go slow, draw a little man and walk through one component at a time. That's easy. So coming up with rules for those are pretty easy. The starting point as well, some people find hard, but I always say, well, what I want to find, R was what I wanted to find. So I need to eventually write some sort of equation that has R in, and that's how I choose my starting point. I say, I'll do a loop with R in it, and then I go from there. So like I said, it seems complicated, but it's made up of a whole lot of small pieces that anyone can do. Good luck.